Assalamu alaikum everyone, welcome to today's video where we will be discussing about operators. So let us get started. Operators, as the names suggest, they mean those who do operations. So while speaking about operators, we need to be accustomed to two names. One is the operator itself and the other is the operand. The operands are the object or the thing that are changed using operators to a different something. We will see examples later on, but first of all what we need is a little description about operators. Operators are actually depending on how many operands are used or needed for the operator to work. Operators can be of three types over here given. One is the unary operator, where it needs only one operand. There is the binary operator that needs two operands. Ternary operator, which needs three operands. Now if I want to give an example, suppose, well, we all know the plus sign. Plus is an operator, okay? So what does the plus do? It does the operation of adding two numbers, suppose A and B. So here A is an operand and B is an operand and plus is the operator. This is the main relation between what's an operator and an operand. So I'm saying over here you can see the sum sign or the addition sign. It actually has two operands. One is A and the other is B, and in order for the addition operator to work, it needs at least two operands in both of its sides. So addition is actually a binary operator because it needs two operands. Similarly, there are some operators that needs only one operand to work. They are called unary operators, and some operators need three operands. They are called ternary operator. In our course, we will be mainly focusing on binary operators and unary operators. In some cases, unary operators. Ternary will not be much of a discussed in our course, but you may need it in later courses or so. So that was based on operators. Now we will see a different type of operators based on their actions. So there are some operators that are called the arithmetic operator. The arithmetic operators work in arithmetic units, or you work with arithmetic. So first is the addition operator, which provides the sign of plus, and it adds both the operands, it adds the numbers. Subtraction, the sign is a minus and it subtracts the first operand from the second one. As you can see, both of them are binary operators. Next step is multiplication. What does the multiplication do? Multiplication sign is this one, okay? So usually in math courses, when we used to work it, you used to give the sign of x to denote multiplication, but not anymore. In computer science we use the asterisk sign, that's the star. This is the multiplication operator in coding. So this symbol will be used for multiplication, and it multiplies the two operands in both of its sides. And the division operator is this one, okay? So this sign is used as the division. It divides the first operand from the second one, and this operator is supposed to be new to most of us. It's called the modulus operator. This is given this percentage sign. What does it do? Well, in division we divide two numbers, right? We are also supposed to be familiar with the term remainder. The remainder of a division operation, it can be accessed by using the modulus operator, which gives us the modulus. So for an example, if I am supposed to say, if I want to divide, suppose let's divide 5 using 2, okay? So what will we get is, here will be 2, here we will get 4, and thus this will be 1. So in this operation we can say that if we give 5 by 2, the result will be this one. which is 2, and if we give 5 modulus of 2, it should provide us the remainder, which is this part. So the answer will be 1. So once again, in division, as we are using integer, you can see this number 5 is an integer and 2 is an integer. So the division result will be an integer and there will not be any decimal points like 2 point something. So the rest of the part will go missing. But the modulus operator, what it does, it just carries the remainder and shows us the answer. So the 5 mod 2 answer will be 1. So this is the work of the modulus operator. We will try to see it in action later in this video when we try to look at some codes. So this is the division and this is the modulus. Please remember that the modulus operator is very much useful and highly used in programming. In fact, there are some limitations to it as well. It's a very heavy operation. Among all the operations of arithmetic, modulus is considered the heaviest operation. So modulus operator, though important, it's also a very heavy operation. But do remember, do study about it. I cannot emphasize enough how important this operator is. So that's the modulus operation done, and also our arithmetic operations are gone. Next up is increment or decrement operator. Increment and decrement operator uses only one operand, so it is an unary operator. What does it do? It only increases or decreases value by 1. Like over here. Okay, the increment decrement is of 2 types. Increment and decrement operators are of 2 types. That is the prefix and suffix. Prefix and suffix are used when it comes to increment and decrement operators. So the prefix operator actually means that the operator itself, which is over here, is the plus plus or the minus minus. Plus plus means increment and minus minus is the decrement. So when the operator comes before the operand, it's called the prefix, and when the operator comes after the operand, it's called the suffix, postfix, sorry. So these are the two types of increment decrement operator. There is some difference between y prefix and y postfix, but to understand the importance, we will first need to go for the loop chapter, which is not yet. But for now, what we can say that yes, this increases the value of I by 1, this decreases the value of I by 1, this increases the value of I by 1, this decreases the value of I by 1. But there are some aspects we will, in fact, probably before loop chapter, we will see a few examples that will help us understand what is the difference between prefix and postfix. In fact, I will try discussing it in this video as well. Assignment operators. Okay, there's not much of a description given over here. Well, we will try to show you that this operator, that is the equal operator, very important in math. Usually this means that the left side is equal to right side. We see equations like a plus b whole square equals to a square plus 2ab plus b square. We have written it in math courses also. In this case, this equal sign actually means that the left hand side and the right hand side are equal, but not in programming. No, they are not. In programming, we say when a equals to 5, what we actually mean that the value of 5 should be given to a. That is when we print a, it will be showing that a is 5. This is the use of equal sign. Very careful about this. In math, equal sign is used to show that the left hand side and the right hand side are equal. But in programming, the equal sign is used for assigning the value of right to the one in the left. So this assignment operator is taking two operands, one is the 5 and other is the a, and it is saying that provide the value of 5 to a. So this is the difference between this operator, this symbol in math and in programming. And other differences, like what does this do? Well, these are actually quite easy to understand if you get through the assignment operator. A plus equals to b is actually same as a equals to a plus b. Same goes for a minus equal to b. If I say this is a minus equals to b, it's similar to a equals to a minus b. This is how these operators work. We will later see in examples all these assignment operators. Next up, relational operator. Now we see this double equals to sign. Okay, now it means what it was meaning in math as 1 equals. That is, the left hand side and right hand side needs to be equal. And one thing you must remember in programming, when anything is said to be true, this will work in C and other languages, other programming languages usually also follow these conventions, but some programming languages usually don't do this. So but as we are mostly discussing C, so you need to remember that when anything is true, C programming provides it with the value of 1, and when anything is false, C programming provides it the value 0. So once again, if something true happens, if something correct happens, if some operation says left hand side equals to right hand side, which is actually true, the output will be 1. And if left hand side and right hand side are not equal, then it will provide 0. So over here there are three operations. The double equals to means that the left hand side and right hand side are exactly equal. Then we have the greater equal to, that means the left hand side is greater or equal to the one in the right. Then is the less equal to, which means the left one is less or equal to the one in right. There is the greater sign, which means the left one is strictly greater than the one in the right, not equal to. The less equal to sign, which means the left one is smaller than the one in the right. And this is the not equal to, which means the left hand side and right hand side values are not equal to each other. These are the relational operator. And if you see in the previous slide, we called it the assignment operator, so it assigns the value. In relational operator, it only compares the sides, so it will either provide us with 1 or 0. Why? I already explained. The true gives 1 and false gives 0. And in relational operator, we are only trying to figure it out whether the relation between two operands is the one I'm trying to say in the middle. Once again, we will see examples regarding it to clarify the situation even more. Next up, logical operators. Okay, so to go for a logical operator, we do need some basics of logic operations. For example, I have only given over here the not, and or. Okay, so let's get started with the not operator. What does the not operator do? We say that if we are given 0, we write the not sign before and it converts into 1, and the not of 1 is given the value 0. This is the not operator and its working principle. Okay, so next comes is the AND operator. So in AND operator, we need at least two variables. A and B. So let's say A is 0, B is 1, B is 0 as well. A is 0, B is 1, A is 1, B is 0, and A is 1 and B is 1. So when we say A and B, so if these both are 0, then we get 0. If 0 1, we also get a 0. When A is 1, B is 0, we again get a 0, and when A is 1, B is 1, the output turns into 1. This is how AND operators work. Usually this is discussed in Boolean algebra, which is beyond the scope of this course, which you should have studied previously, uh, but we can discuss about it in the class if you are interested. This is how the AND operators work. And similarly, if you want to work with the OR operator, once again we need two operands A, B, and we need the A or B part, which essentially says that if a 0 0, then the output will be 0, and in all other cases the output will be 1. This is the logical operator. Please remember that logical operators are usually teamed up with relational operators, and by combining them we do some conditional works. Logical operators usually do not come alone, but yeah, they can come alone, but usually they are mixed up using relational operators to form complex logics to work in different cases. Next up, bitwise operator. Usually we will not be needing it much, and usually programmers use it for high level operations. By high level operations I mean that some special cases, because bitwise operators actually work with binary digits or bits in specific case. For example, if you provide a number 5 and give a not sign to it, then first it will convert it into a binary. The binary of 5 is 101, and then it will convert it back, then it will convert all the bits by making it 0 1 0. This is how it works actually. So 101 will be converted to 010. If you use the bitwise AND operator, and if you give 5 and suppose 3, 5 and 3, what it does is that it first generates the binary of 5, which is 101, then it generates the binary of 3, which is 011, and then it does a logical bitwise AND operation between these numbers. So 1 and 1 will equal to 1, 1 and 0 will equal to 0, 1 and 0 will equal to once again 0. So if we do 5 bitwise AND of 3, the answer will be this, and it will be then converted back to an integer number, which will be 1. Similarly, when you use the OR operation, it will do bitwise OR, which will mean this will become 1, this will become 1, this will become 1, and when you convert it, the answer will become 7. Similarly, we use the XOR operation, and the right shift and the left shift all are used in binary levels. Given the number, they first convert it into given decimal numbers, also first they convert it into binary numbers, and then those binary numbers are converted back into decimal numbers. So that's for today. That's all for today. We will try looking at some codes now for a better understanding of what's going on. Okay. So here we are. We will start coding over here. So first up in our operations, we saw arithmetic operators. So let's get started. Oh, let's get started. Okay, for set the new lines. Okay, let's see, 5 and 4, 5 plus 4 added, it's 9. Then we have 1, 5 into 4 is 20 over here. By dividing 5 by 4 we get 1, and 5 modulus 4 is 1 as well. If you want to see different outputs over here, you can say 3, and this is also 3. Then we get over here is 1 and 2, which I explained in the video, how the modulus operators works and such. So these are all arithmetic operators. Okay, next up is assignment operators, which I discussed. First of all, we can give integer a equals to, I don't know, maybe 4, or let's give it a 7, and we can assign another integer b given the value of 8. So now if we print the values, the value of a %d tab, the value of b %d, then we give a new line, and if we provide the values of a and b and run it. Okay, a is provided 7 and b is given 8, so this is working actually. Let's give it a little smaller value for a change, and okay. So now we are actually working with assignment operators. Okay. Now if we actually work it out, we can actually see, let's declare a different variable, suppose integer c. Okay, so if we say c equals to a plus b, and then we say a plus equals to b, and then we see printf the results and give a %d over here, and first we print the value of c, then we print the updated value of a. Okay, so and then run it. Okay, oh, I only get one format specifier over here, so this should not work. Okay, over here I can see that the results are both identical. That is, if I differently add them and store them in a number, or if I write a plus equals to b, the results are actually the same, as you can see over here, 11 and 11. Well, let's change the values a bit. I think we can give it an 8 and give this a 3, suppose, and then okay, yeah, ultimately the result will remain the same. Let's give it a, I don't know, 36 or just a 6. Look at this becomes 14 and 14. So identically, just as showed in the slide, you can give any other symbol. Okay, let's give the modular symbol for a change. See, once again, 2 and 2. So identically the same. This is how assignment operators are working stuff out. Extra new line. After assignment operators, we work with logical operators. Okay, so let's keep a and b as they are, which is okay. I'll remove this line for a change. Okay, let's remove these lines for a change. Now we will start working with logical operators. Okay, so let's get started. Printf the value of a double equals to b. So let's write a double equals to b. This is how we write it. This is how we write it. The value of a double equals to b. See, we have written it like this, and we can see that a is currently 8 and b is currently 6. So when we run it, the output is 0, which is, yeah, quite right, because they're not actually equal to. But what happens if I say that a is 8 and b is also 8 and compare them? Now just look at that, the answer becomes 1. So when the conditions are correct, the output will become 1, and when the conditions are incorrect, the output will be 0. For example, if I say a is greater or equals to b, this is also correct because 8 is greater or equals to 6, and hence when I provide this condition, a is greater or equals to b, let's make this one correct as well. As you can see, the answer is 1. So this is how logical operators work. The different existing operations are actually same as they are. Okay, now comes relational operator. Okay, so relational operators, as I said, integer. I'm going to declare this. Now I'm going to say printf not divide them using tabs instead. Or MD and tab. These are all we discussed, right? So let's give it a new line, and then we have this. Okay, so okay, so we have the pause, let's give it a not. We have the nos, let's give it a not. Then we start by saying nos and nos, and we say nos or nos. Okay, let's change this part to pause, and this one is pause. Now make this pause, make both. Okay, now look at this. Okay, these are the not parts, so you really don't need much of it. What we need to see over here is this part, the 0, 0 and 1 parts, just as I explained. When in case of AND, only when both the values were 1, the output was given 1, in other cases 0, and in case of OR, only when both of them were 0, the output became 0, in other cases it was 1. So this is the relational operator. I will not take the time in explaining the bitwise operation. As I mentioned, it's a little bit complex. So this is all for today. Thank you everyone. See you in the next class.